June 6, 1944, 0630 hours, Omaha Beach, Normandy. Staff Sergeant Philip Strechik of the 16th Infantry Regiment, 1st Infantry Division, pressed his face against the cold steel of the landing craft as German machine gun fire ripped through the air inches above his head. Around him, men were dying before they touched French soil, cut down in water turned red by American blood. The ramp had dropped into hell itself. 6 feet of water, a 200-yard killing zone, and beach obstacles crowned with mines that had already torn apart 3 landing craft in his wave alone. But Strechik carried something the Germans hadn't anticipated. Strapped to his back in waterproof canvas was a weapon that would prove more decisive than any rifle or grenade. 10 feet of assembled steel tubes, each section 2 inches in diameter, filled with 8 pounds of composition C2 explosive. The Bangalore Torpedo, a device so simple the Germans dismissed it as a relic from the trenches of the First World War. They were about to discover that simplicity, when backed by American industrial production and desperate courage, could break the most formidable defensive position ever constructed. What the German defenders of Widerstands Nest 62, Resistance Point 62, couldn't know as they poured fire into the landing. Americans was that this crude pipe bomb represented the culmination of American engineering philosophy. Not sophisticated, not elegant, but mass-produced by the tens of thousands, simple enough that a terrified soldier could assemble it under fire, and effective enough to blast through obstacles that German engineers had spent years perfecting. The story of how a simple explosive tube broke Fortress Europe begins not on the beaches of Normandy, but in the desperate calculations of American engineers who understood that the Atlantic Wall would require not just courage, but the right tools for breaching concrete, steel, and wire. The Atlantic Wall, that faced the Allies on June 6, 1944, represented the most comprehensive defensive system ever constructed. Field Marshal Erwin Rommel, given command of Army Group B defending France in January 1944, had worked frantically to strengthen Hitler's vaunted coastal fortifications. His experience in North Africa had taught him that Allied material superiority meant Germany's only chance lay in stopping invasions at the waterline. Every day the Allies spent establishing a beachhead would bring more men, more tanks, more supplies that Germany simply couldn't match. Rommel's approach to beach defense was ruthlessly practical. He ordered the construction of extensive obstacle belts extending from high water mark down to low tide. The obstacles came in several varieties, each designed to rip apart landing craft or detonate explosives that would kill the men inside. Belgian gates, steel frameworks 10 feet high topped with mines. Czech hedgehogs, 3 steel rails welded together in X patterns that could tear the bottom from landing craft. Tetrahedrons, pyramid-shaped concrete obstacles studded with steel. Element C, curved steel rails embedded in concrete bases with mines attached. Ramps, angled steel beams designed to direct landing craft onto mines. The statistics of Omaha Beach's defenses were staggering. German engineers had planted approximately 3,700 obstacles along the 7,000-yard beach between Vierville and Colleville. Each obstacle potentially carried mines, typically teller mines designed to destroy tanks but equally effective against landing craft. The density increased near the waterline, where Rommel knew the Allies would attempt to land at high tide to minimize exposure time crossing the beach. In some sectors, obstacles stood less than 10 feet apart, creating an impenetrable maze of steel and explosives. Beyond the obstacles lay the beach itself, carefully prepared as a killing ground. 3 belts of barbed wire, each 3 feet high with concertina coils between posts. Anti-tank ditches 12 feet wide and 6 feet deep. Anti-personnel mines by the thousands, both the S-mines that bounded into the air to spray shrapnel and the simpler shoe mines designed to blow off feet. The German defenders had cleared fields of fire extending hundreds of yards, removing vegetation and obstacles that might provide cover. Every inch of sand was covered by interlocking machine gun positions, mortar pits, and artillery emplacements. The fortifications themselves demonstrated German engineering excellence. 75 concrete pillboxes and casemates lined the bluffs overlooking Omaha Beach. The concrete, reinforced with steel, was 6 feet thick in places, proof against all but direct hits from naval guns. The embrasures, firing ports, were carefully designed to provide maximum fields of fire while exposing minimum target to Allied ships. Each position connected to others through trenches and tunnels that allowed defenders to shift positions and maintain fire even when specific bunkers were hit. The 352nd Infantry Division defending Omaha Beach consisted of approximately 7,800 men, more than intelligence had estimated. These weren't the understrength coastal defense units of old men and reluctant conscripts that defended other sectors. The 352nd was a combat-effective division that had been training intensively for months. They knew every meter of their defensive sector. They had rehearsed countless scenarios. They were confident that any landing at Omaha would be massacred. The German defensive philosophy relied on what they called Schwerpunkt, the decisive point. Rather than trying to defend everywhere equally, they concentrated overwhelming firepower at the most likely invasion points. Omaha Beach, with its limited exits through the bluffs, was an obvious target. If the Allies took Omaha, they would have a clear path inland to link the American landing zones. If Germany held Omaha, the entire invasion could be thrown back into the sea. American planners understood the challenge. The initial plans for Operation Overlord, developed through 1943, called for extensive naval bombardment and aerial bombing to destroy the Atlantic Wall before troops landed. The final bombardment plan for Omaha included 40 minutes of naval gunfire from battleships, cruisers, and destroyers, plus heavy bomber strikes. The theory was sound. Reduce the fortifications to rubble, suppress the defenders, then land assault troops who would mop up surviving resistance. But theories created in London conference rooms often collapsed when meeting reality. The naval bombardment on the morning of June 6th proved inadequate. Poor visibility from smoke and mist prevented spotters from accurately directing fire. The battleships USS Texas and USS Arkansas, along with cruisers and destroyers, fired thousands of shells. But the German bunkers, embedded in the bluffs with minimal exposure, survived largely intact. The aerial bombardment was even less effective. Concerned about hitting the landing forces, bomber crews delayed their drops by seconds. Those seconds, at 180 miles per hour, meant bombs fell inland, churning up empty fields while leaving beach defenses untouched. The amphibious tanks that were supposed to lead the assault and provide mobile firepower largely sank in rough seas. Of 29 D.D. Sherman tanks launched from landing craft, 6,000 yards offshore, 27 sank immediately, their flotation screens no match for 4-foot waves. The 2 that made it to shore arrived after the first infantry waves, finding themselves isolated and quickly knocked out by German anti-tank guns. When the first landing craft lowered their ramps at 0630 hours, the men of the 1st and 29th Infantry Divisions faced the Atlantic Wall at full strength. The German defenders, having survived the bombardment in their deep bunkers, manned their weapons and began systematic destruction of the landing forces. The MG-42 machine guns, capable of firing 1,200 rounds per minute, created intersecting fields of fire that no one could survive standing. Men jumped from landing craft into water over their heads, weighed down by equipment that dragged them under. Those who made it to shallow water faced 200 yards of open beach with no cover. Within the first hour, casualties on Omaha Beach approached 2,000 men. Entire companies were effectively destroyed. Company A of the 116th Infantry Regiment, landing at 0636 hours, lost 96% of its strength in the first 10 minutes. Of 200 men who left the landing craft, only 8 remained effective by 0700 hours. Medics, who should have been protected by the Geneva Convention, were shot down as they tried to help wounded men. Officers attempting to organize their units were targeted specifically by German snipers. The carefully prepared assault plan was disintegrating into chaos and slaughter. The German defenders watched with grim satisfaction as their defensive system worked exactly as designed. Oberleutnant Bernhard Fröking, commanding the strongpoint at Widerstands Nest 62, later testified that the initial assault appeared to be failing completely. The Americans were pinned at the waterline, unable to advance across the exposed beach. Casualties were mounting by the minute. If this rate of destruction continued, the landing would fail within hours. Germany would have its propaganda victory, proof that Fortress Europe was impregnable. But Fröking and his men didn't account for American adaptability and the tools that some of those struggling soldiers carried through the surf. Among the chaos, small groups of engineers and infantry were assembling sections of pipe into longer lengths, preparing to do what the naval bombardment and aerial bombing had failed to accomplish. They were about to introduce the Bangalore Torpedo to the Atlantic Wall. The Bangalore Torpedo's origin traced back to the trenches of World War I. Captain R.L. McClintock of the British Indian Army invented the device in 1912 at the Bangalore station in India, hence the name. The original design was elegantly simple. Steel tubes filled with explosive that could be pushed under barbed wire and detonated to clear a path. During the First World War, both British and American forces used Bangalore torpedoes extensively to breach the elaborate wire obstacles that characterized trench warfare. By 1944, the design had evolved but remained fundamentally unchanged. The American M1A1 Bangalore torpedo consisted of sections of steel tubing, each 5 feet long with a 2-inch diameter. Each section held approximately 8 pounds of composition C, 2 explosive, a stable but powerful mixture that could withstand rough handling. The sections featured threaded coupling mechanisms that allowed soldiers to screw multiple tubes together, creating lengths of up to 50 feet or more. A nose cone attached to the lead section, while a firing mechanism and detonator attached to the rear. The simplicity was deliberate. American engineers designing equipment for mass production and field use understood that complicated mechanisms failed in combat. The Bangalore had no moving parts beyond the simple threaded couplings. Any soldier with basic training could assemble the sections by screwing them together, even in darkness or under fire. The detonation system used standard military blasting caps and time fuse or electrical firing systems, both well understood by combat engineers. Production of Bangalore torpedoes exemplified American industrial capacity. Multiple manufacturers produced sections to identical specifications, ensuring complete interchangeability. A section made in Pittsburgh would couple perfectly with one made in Chicago. The tolerances were precise enough to prevent leakage of explosive, but loose enough that sand, water, or damage wouldn't prevent assembly. This industrial standardization, boring in concept, proved crucial in combat where equipment from different units needed to work together. The weight proved both advantage and curse. Each 5-foot section weighed approximately 12 pounds. A soldier carrying 2 sections, 10 feet of assembled Bangalore, bore 24 pounds in addition to his weapon, ammunition, and other equipment. In the water off Omaha Beach, that weight nearly drowned many engineers. But the weight also meant the torpedo would stay in place once positioned, not blown around by explosions or wind. The steel construction could withstand considerable abuse without rupturing and setting off the explosive prematurely. Training for Bangalore employment was intensive for combat engineer units. At Fort Belvoir, Virginia, and other engineer training centers, soldiers practiced assembly under increasingly difficult conditions, first in daylight on stable ground, then in darkness, then in water, then while instructors fired weapons nearby to simulate combat stress, then while wearing full equipment and gas masks. The goal was to make the assembly process automatic something a soldier could do without thinking even while terrified and under fire. The tactical employment doctrine emphasized teamwork. A Bangalore team consisted of at least 3 men, one to assemble and position the torpedo, one to handle detonation, and one to provide security. In practice, teams were often larger, with multiple soldiers carrying sections that would be combined into a single long charge. The standard procedure called for assembling the torpedo on the friendly side of the obstacle, pushing it forward under the wire or obstacles until the nose extended past the far side, then retreating to cover before detonation. The explosive effect of a properly positioned Bangalore was devastating. 8 pounds of C2 per section meant a 40-foot Bangalore carried 64 pounds of explosive. When detonated, this created an explosive cut approximately 10 feet wide through wire obstacles. The blast shredded wire, destroyed mine trip wires, and often sympathetically detonated nearby mines. The concussion could kill or stun personnel within 50 feet. Debris, torn wire, and fragments of destroyed obstacles became shrapnel that could wound at even greater distances. For the D-Day invasion, each assault regiment received Bangalore torpedoes in significant quantities. The 16th Infantry Regiment, landing on the eastern half of Omaha Beach, carried approximately 200 Bangalore sections distributed among its engineer platoons and assault companies. The 116th Infantry Regiment on the western half carried similar numbers. These weapons were carefully packaged in waterproof canvas to prevent water damage during the amphibious landing. The packaging added bulk, but was essential given that the tubes had to survive immersion in salt water. The 37th and 336th Engineer Combat Battalions, organic to the assault divisions, carried even more extensive Bangalore stocks. These specialized engineer units had trained specifically for obstacle clearance. Their mission was to clear paths through the beach defenses within the first hour of landing, allowing vehicles and follow-on forces to move inland. Each engineer battalion carried approximately 400 Bangalore sections, enough to create multiple cleared lanes if everything went according to plan. The Navy also recognized the Bangalore's importance. Aboard the landing craft carrying the first waves were additional Bangalore sections stored with other engineer equipment. The Navy's underwater demolition teams, though primarily focused on obstacles below the waterline, also carried Bangalores for dealing with obstacles at the high tide line. This redundancy proved crucial when casualties disrupted the carefully planned distribution of equipment. The planning documents for Omaha Beach specified that engineers would land in the first wave and immediately begin clearing obstacles. The timeline was brutally optimistic. H-hour plus 30 minutes, 16 gaps cleared through the obstacles. H-hour plus 1 hour, obstacles fully cleared with marked lanes. H-hour plus 2 hours, vehicles moving freely up the beach exits. These timelines assumed minimal casualties, effective fire suppression from naval guns and tanks, and German defenders still stunned by the bombardment. Reality on June 6th bore no resemblance to the plan. When the first engineers landed at 0630 hours, they found themselves in a massacre. Landing craft were being destroyed by mines before reaching shore. Those that made it faced murderous fire that killed or wounded men before they could even exit the craft. The engineers, easily identified by their equipment and markings, were priority targets for German machine gunners who understood that obstacle clearance was the key American task. Lieutenant John Spaulding's platoon from the 16th Infantry Regiment, landing in the first wave, watched as the engineers detailed to their sector were decimated in the first minutes. Of 12 engineers who landed with his platoon, only 3 made it to the beach unhurt. The Bangalore sections they carried were lost in the water when the men were hit. Spaulding's own soldiers, infantrymen with minimal engineer training, would have to attempt the obstacle clearance themselves. Staff Sergeant Stretchick's experience was typical of what many engineers faced. Landing under heavy fire, his team struggled through chest-deep water while German machine guns traversed the beach systematically. The soldier carrying the detonating equipment took a burst of machine gun fire and went down in the surf. Another engineer, hit in the legs, tried to crawl forward but couldn't make progress through the water. Strechik and 2 others made it to the beach, but they had only the Bangalore sections they personally carried, no detonators, and German fire so intense that moving was nearly suicidal. The chaos of combat created situations the training had never addressed. Bangalore sections from different teams were scattered across the beach, mixed with other equipment, some still in waterproof wrapping, others torn open by shrapnel. Engineers from different units, whose officers were dead or wounded, tried to coordinate with hand signals and shouted orders, often drowned by explosions. The carefully trained 3-man teams had become individual soldiers, trying to improvise under conditions of absolute terror. Yet despite the catastrophic casualties and complete breakdown of the assault plan, some engineers began attempting to employ their Bangalores against the German obstacles. The first recorded successful Bangalore attack occurred at approximately 700 hours, 30 minutes after the initial landing, in the sector designated Easy Red. A team of engineers from the 37th Engineer Combat Battalion, led by Sergeant John Fulcher, managed to assemble a 20-foot Bangalore under the cover of the seawall, a low concrete barrier at the high tide line that provided minimal protection. Fulcher's team had lost half its members getting to the seawall. The survivors gathered scattered Bangalore sections from dead engineers and assembled them by feel, their hands shaking from fear and cold. They had no detonators, those having been lost in the water, but Fulcher improvised using a grenade. He attached a grenade to the detonating end of the Bangalore using wire scavenged from the beach obstacles, pulled the pin, then he and his men sprinted away and threw themselves flat. The explosion, when it came, was spectacular. The 20-foot Bangalore, positioned under a section of concertina wire backed by a minefield, detonated with a blast that was felt hundreds of yards away. The wire disintegrated. Several mines sympathetically exploded, creating a secondary series of blasts. When the smoke cleared, a gap approximately 15 feet wide extended through the wire and mines. It wasn't the neat, cleared lane that the plan called for, but it was a breach. American soldiers nearby saw it and began moving forward through the gap. The psychological effect of that first successful breach was profound. For the past 40 minutes, the assault troops had been pinned down, watching men die all around them, with no way to fight back effectively. The German positions were too well protected for rifle fire to suppress. The naval gunfire couldn't hit the bunkers. The soldiers couldn't advance through the obstacles and mines. Many were beginning to think the landing had failed, that they would all die on this beach. Then the Bangalore exploded and created a path forward. Within minutes, other engineer teams began attempting similar breaches. Staff Sergeant Strechik, having scrounged a detonator from a dead engineer's pack, assembled a 30-foot Bangalore from sections scattered across the beach. Working with Corporal Louis Ramundo and Private First Class Leo Nash, Strechik positioned the torpedo under a Belgian gate obstacle crowned with 3 teller mines. The obstacle, a massive steel framework 10 feet high, had stopped 2 landing craft already, detonating mines that killed everyone aboard. Strechik's Bangalore placement was textbook perfect despite the circumstances. He and Ramundo crawled forward, pushing the sections ahead of them through sand churned up by explosions. German machine gun fire kicked up sand around them, but the defenders' angle of fire was just barely too high, the bullets passing inches overhead. When the Bangalore extended fully under the Belgian gate and out the other side, Strechik attached the blasting cap, unwound 50 feet of firing wire, and called for everyone nearby to take cover. The detonation of 30 feet of Bangalore, containing 48 pounds of explosive, was massive. The Belgian gate disappeared. The 3 teller mines detonated simultaneously. The explosion created a crater 6 feet deep and 20 feet across. Wire obstacles for 30 yards in either direction were destroyed by the blast and flying debris. When American soldiers cautiously approached the crater, They found they could walk through, scrambling down one side of the crater and up the other. The path was rough, but it was passable. By 0730 hours, approximately 1 hour after the initial landing, small breaches were appearing along Omaha Beach. None were the marked, cleared lanes that the plan called for. Most were rough gaps blown through obstacles by improvised Bangalore attacks. But they were enough. Small groups of infantry began moving through the breaches, getting off the beach and starting to climb the bluffs toward the German positions. The German defenders recognized the danger immediately. Oberlieutenant Fröking, watching from Widderstand's Nest 62, ordered his machine gunners to concentrate fire on any breach they observed. He directed mortar fire onto the gaps, trying to make them impassable. But the Americans kept coming. For every breach the Germans tried to suppress with fire, another would appear elsewhere. The Bangalore Torpedoes, simple pipes filled with explosive, were defeating the carefully constructed Atlantic wall defenses through sheer numbers and the desperate courage of the men employing them. The breakthrough that changed the entire battle occurred at approximately 0800 hours in a sector designated WWII. Here, elements of the 116th Infantry Regiment, 29th Infantry Division, had been pinned down since landing. Casualties exceeded 60%. The survivors clung to whatever cover they could find, mostly shell craters and the minimal protection of a gravel embankment. German fire from Widderstand's Nest 71, a strong point dominating this sector, made movement impossible. Then Brigadier General Norman Cotta, Assistant Division Commander of the 29th Division, arrived on the beach. Cotta, at 51 years old, was well beyond the age when most officers led from the front. But recognizing that the assault was on the verge of failure, he had come ashore to personally rally the troops. Moving along the beach, seemingly oblivious to German fire, Cotta found a group of engineers and infantry huddled behind the embankment. His orders were direct and profane. He demanded to know who had Bangalore torpedoes. Several soldiers indicated they had sections. Cotta organized them on the spot, designating who would assemble the torpedo, who would detonate it, and who would lead the assault through the breach once created. He positioned himself where he could observe the entire operation and gave the order to proceed. The engineers assembled a 40-foot Bangalore, the longest yet attempted on Omaha Beach. They positioned it to breach not just the wire and mines at the base of the bluff, but to create a path through a thicker band of obstacles extending 20 yards inland. The detonation, when it came, was the largest explosion yet on the beach. 64 pounds of composition C2 created a blast that was heard over the sounds of battle. The breach it created was dramatic, a ragged gap 30 feet wide extending through multiple obstacle belts. Cotta personally led the assault through the breach. Shouting for soldiers to follow him, he ran through the gap and up the bluff before German defenders could recover and bring fire to bear. Soldiers from multiple units, inspired by his leadership, followed. Within minutes, over 100 American troops had made it through the breach and were engaging German positions from behind. The Atlantic Wall, at this point, had been breached not by naval guns or tanks, but by a simple, explosive pipe and raw courage. The success at WWII triggered a cascade of similar breaches. Soldiers all along Omaha Beach, seeing that the obstacles could be defeated, redoubled their efforts. Engineers who had been scattered and disorganized began reforming teams. Infantry soldiers with no engineer training picked up Bangalore sections from casualties and attempted their own breach operations. The carefully trained doctrine was abandoned in favor of improvisation, but the result was the same. Gaps were appearing in the German defenses faster than the defenders could respond. By 0900 hours, approximately 2.5 hours after the initial landing, the crisis at Omaha Beach had passed. The assault that had seemed on the verge of catastrophic failure was succeeding. Small groups of American soldiers were fighting their way inland, getting among the German positions, forcing the defenders to abandon their carefully prepared fields of fire. The German strongpoints, so effective when firing down on the beach, became vulnerable once Americans got behind them. The Bangalore Torpedo had proven to be the essential tool that broke the Atlantic Wall. Not through sophisticated technology or overwhelming power, but through simplicity, availability, and the courage of the men who employed them under impossible conditions. The crude pipe bombs that German engineers had dismissed as obsolete accomplished what battleship guns and heavy bombers could not. They created paths through obstacles that allowed infantry to close with and destroy the defenders. The afternoon of June 6th saw continued use of Bangalores as follow-on forces expanded the beachhead. The initial gaps, blown through obstacles in desperate circumstances, were rough and inadequate for vehicles. Engineer units, having regrouped and organized, began systematic clearing operations. They used Bangalores to expand existing breaches, creating lanes wide enough for trucks and tanks. They cleared additional paths through areas where no gaps existed, methodically destroying the obstacle belts that had taken German engineers months to construct. The technique evolved through practice. Engineers discovered that longer Bangalores, 50 feet or more more effective but harder to position. They learned to use shorter charges in series, detonating them sequentially to create longer cleared paths. They developed methods for clearing mines adjacent to breaches using Bangalores positioned parallel to the path rather than perpendicular. Each lesson was learned in combat and immediately shared among the engineer units. By nightfall on June 6th, the 37th and 336th Engineer Combat Battalions had cleared 16 vehicle lanes through the beach obstacles, achieving the initial goal, albeit 6 hours late. They had expended over 600 Bangalore sections, far more than planned, but the redundancy built into American logistics meant additional supplies were readily available. The engineers had also suffered terrible casualties, over 40% in some platoons. But the survivors had proven that American engineering doctrine worked even under the worst possible conditions. The German defenders' reports that survived the battle documented their shock at American obstacle breaching capability. Multiple reports mentioned the effectiveness of the pipe explosives that destroyed obstacles faster than they could be replaced. One German engineer officer, captured on June 7th, stated in interrogation that he had dismissed the Bangalore as outdated before the battle, assuming that modern obstacles would require more sophisticated breaching methods. He acknowledged that the simplicity of the device was actually its strength, allowing mass employment by soldiers with minimal training. The cost of breaking the Atlantic Wall at Omaha Beach was terrible. American casualties on June 6th exceeded 2,400 men, killed, wounded, or missing. The 1st and 29th Infantry Divisions were significantly weakened. Some companies had effective ceased to exist, but the beachhead was secure, and within days, over 100,000 American troops with thousands of vehicles had passed through Omaha Beach and moved inland. The Atlantic Wall, which Hitler had proclaimed impregnable, had been breached in less than 12 hours. The Bangalore Torpedo's role in this victory was later acknowledged in after-action reports and historical analyses. General Omar Bradley, commanding American forces at Omaha Beach, wrote in his memoir that the Bangalore Torpedo was one of the 3 most important weapons of the landing, alongside the rifle and the Browning automatic rifle. He credited the engineers' skillful and brave employment of Bangalores with creating the initial breaches that saved the assault from failure. The irony was not lost on military historians. The Atlantic Wall, product of years of German engineering effort, sophisticated concrete fortifications, carefully designed obstacles, elaborate minefields, had been defeated by a weapon invented in 1912. The Bangalore Torpedo, a device so simple it could be manufactured in any machine shop, operated by soldiers with minimal training, had proven more decisive than battleships or bombers. The success of the Bangalore Torpedo at Omaha Beach reflected deeper truths about American military philosophy and industrial capacity. While German engineers had spent years constructing elaborate defenses, American engineers had focused on developing simple, reliable tools that could be mass-produced and employed by average soldiers under combat stress. This philosophical difference would characterize the entire war and ultimately determine its outcome. American military engineering doctrine emphasized simplicity and redundancy. Complex equipment that required specialized training or careful maintenance was deliberately avoided in favor of robust designs that could withstand abuse. The Bangalore embodied this philosophy perfectly. Its threaded couplings could be assembled by feel in darkness. The explosive composition remained stable even when dropped, immersed in water, or subjected to temperature extremes. The detonation system used standard military fuses that any soldier understood. This simplicity meant that when trained engineers became casualties, as happened throughout the Omaha landing, infantrymen could pick up the weapons and employ them effectively. Production of Bangalores demonstrated American industrial capacity at its peak. The steel tubing came from multiple mills across the United States, all manufacturing to identical specifications. The explosive filling was mixed at specialized facilities operated by DuPont, Hercules Powder Company, and other chemical manufacturers. The threaded couplings were precision machined in dozens of small shops that normally made pipe fittings or automotive parts. Assembly occurred at ordnance depots where workers, many of them women, carefully loaded the explosive into tubes, attached end caps, and packaged the finished weapons for shipment overseas. The numbers told a story of overwhelming material superiority. By June 1944, American ordnance depots had produced over 500,000 Bangalore torpedo sections. This was enough to create 50,000 complete 50-foot torpedoes, far more than could possibly be used in any single operation. But American logistics doctrine emphasized abundance. Rather than calculating minimum requirements and producing exactly that number, planners multiplied estimated needs by factors of 3 or 4 to ensure that losses, damage, and unexpected requirements wouldn't create shortages. This abundance meant that when the initial Bangalore stocks at Omaha Beach were depleted or lost, replacements arrived within days. Landing ships bringing follow-on forces carried additional engineer supplies, including thousands more Bangalore sections. By June 10th, just 4 days after the initial landing, engineer units reported they had more Bangalores available than on D-Day, despite having expended over 600 sections. This logistical depth, incomprehensible to German forces struggling with scarcity, exemplified American industrial warfare. The contrast with German obstacle construction revealed the asymmetry at the heart of the campaign. Each Belgian gate obstacle required approximately 400 pounds of steel fabricated to specific designs, transported to the beach, and carefully positioned. German engineers estimated that placing obstacles along Omaha Beach had consumed 1.2 million man-hours of skilled labor. The Bangalores that destroyed these obstacles required minimal skilled labor to produce, could be assembled by any soldier in minutes, and were available in effectively unlimited quantities. American industry had found the perfect counter to German engineering, not through superior sophistication, but through superior production. The tactical evolution of Bangalore employment continued throughout the Normandy campaign. After the initial desperate improvisations at Omaha Beach, engineer units developed more refined techniques. They learned optimal charge placements for different obstacle types. They discovered that angling Bangalores created wider breaches than perpendicular placement. They developed methods for using Bangalores to clear building rubble in urban combat, a capability not envisioned in the original design. The hedgerow fighting that dominated Normandy combat in June and July 1944 saw extensive Bangalore use. The bocage terrain, small fields separated by ancient hedgerows, consisting of thick vegetation growing on earthen mounds, created defensive positions as formidable as any fortification. German defenders would position machine guns and mortars behind hedgerows with clear fields of fire across the adjacent fields. American infantry, attempting to advance across these fields, suffered terrible casualties. Engineers discovered that Bangalores could breach hedgerows effectively. A 30-foot torpedo pushed through the base of a hedgerow and detonated would blow a gap 10 feet wide, killing any defenders in the immediate vicinity and stunning others. Infantry could then assault through the breach before defenders recovered. This tactic, developed through trial and error by soldiers in contact with the enemy, was disseminated through after-action reports and became standard procedure throughout Normandy. The adaptation extended to urban warfare as French cities became battlegrounds. In Saint-Lô, Caen, and dozens of smaller towns, German defenders created strong points in stone buildings. The thick walls were proof against rifle fire and even machine gun fire. Tanks could destroy buildings, but often couldn't maneuver through the narrow streets. Engineers found that Bangalores placed against walls could breach them, creating entry points for assaulting infantry. The explosive force, designed to cut wire, was equally effective at shattering masonry. By August 1944, as Allied forces broke out of Normandy and began the race across France, Bangalore employment had become routine throughout American forces. Every infantry battalion had soldiers trained in Bangalore tactics. Every assault plan included provisions for obstacle breaching using Bangalores. The simple pipe bomb had evolved from a specialized engineer tool to a standard infantry weapon, a transformation that demonstrated the American military's ability to learn and adapt under combat conditions. The Germans, meanwhile, struggled to counter the Bangalore threat. Their initial response was to increase obstacle density, adding more wire, more mines, more physical barriers. But this played into American strengths. More obstacles simply required more Bangalores, and American industry could produce Bangalores faster than German engineers could place obstacles. Some German units tried positioning obstacles in patterns that would be harder to breach with linear charges. But American engineers adapted by using multiple Bangalores from different angles. A more sophisticated German response involved attempting to interdict Bangalore attacks before they could be executed. Snipers were instructed to target soldiers carrying the distinctive long tubes. Machine gunners were directed to sweep areas where engineers might be assembling charges. Mortar crews prepared to fire on any suspected breach attempts. These tactics achieved some success, killing or wounding engineers attempting to position Bangalores. But the fundamental problem remained. If Americans could get a Bangalore into position and detonate it, the obstacle would be breached. No amount of defensive fire could prevent the explosion once the charge was placed. German after-action reports from Normandy increasingly mentioned American breaching capabilities as a critical factor in defensive failures. A report from the 352nd Infantry Division, dated July 15, 1944, stated, "Enemy engineers demonstrate exceptional skill and courage in obstacle clearance. Their pipe explosive charges can breach any obstacle we have constructed. Casualties among their engineers are heavy, but they appear to have unlimited replacements. Our defensive positions are effective only until the enemy creates a breach. Then our interlocking fields of fire are compromised, and positions must be abandoned." This assessment identified the core issue. German defenses were designed around the assumption that obstacles would channel attackers into killing zones. When Bangalores created breaches in unexpected locations, the entire defensive scheme collapsed. The defenders had prepared for frontal assaults through predictable routes. They couldn't adapt to American forces creating new routes wherever obstacles existed. The tactical flexibility that Bangalores provided to American assault forces neutralized the German defensive advantage. The psychological impact on German defenders was significant. Soldiers manning defensive positions knew that American engineers could breach their obstacles. They knew that once a breach occurred, American infantry would pour through and overwhelm the position. This knowledge created a sense of inevitability. Defensive positions that should have been confidence-inspiring instead felt temporary. German soldiers defending behind obstacles knew they were buying time, not achieving security. Conversely, American assault forces gained confidence from Bangalore capability. Soldiers attacking German positions knew that if they could get engineers forward with Bangalore's, they could breach any obstacle. This knowledge translated into aggressive tactics. Rather than being deterred by obstacles, American units saw them as temporary impediments that explosive charges would remove. The psychological advantage of having a reliable solution to obstacles cannot be overstated. It transformed defensive barriers from intimidating obstacles into problems with known solutions. The industrial story behind Bangalore production exemplified American wartime mobilization. The weapon's simplicity meant that production could be distributed across hundreds of facilities. Steel mills rolling pipe for civilian use could easily switch to military specifications for Bangalore tubes. Machine shops making threaded pipe fittings for plumbing could manufacture Bangalore couplings. Chemical plants producing commercial explosives could formulate composition C2 for military use. This distributed production made the weapon nearly impossible to interdict through strategic bombing, unlike more complex weapons that required specialized facilities. The workforce producing Bangalore's reflected America's democratic mobilization. At ordnance depots where tubes were filled with explosives and assembled into finished weapons, women comprised over 60% of the workforce by 1944. These women, many with no previous industrial experience, learned to handle explosives safely and maintain the precise quality control that military ordnance required. Their work was dangerous. Accidents at ordnance facilities killed hundreds of workers during the war, but they persisted because they understood that soldiers' lives depended on reliable weapons. The logistics of getting Bangalore's from American factories to French beaches demonstrated the unparalleled American supply system. Completed weapons were packed in waterproof containers, loaded onto rail cars, transported to ports, loaded onto cargo ships, transported across submarine-infested Atlantic, unloaded in Britain, stored in depots, issued to units, loaded onto landing craft, and delivered to combat units. This process, repeated millions of times for countless items, worked so smoothly that American soldiers could focus on fighting rather than scrounging for supplies. The abundance this created was staggering. By July 1944, engineer supply depots in Normandy held over 50,000 Bangalore sections despite continuous combat consumption. American forces were using Bangalore's at rates that would have exhausted German supplies within days. Yet American stocks increased rather than decreased. This material abundance reflected not just production capacity, but organizational excellence. The Quartermaster Corps, often overlooked in military histories, achieved logistical miracles daily, ensuring that everything from Bangalore's to bandages reached the front lines. Statistical analysis of Bangalore employment in Normandy revealed their decisive impact. Engineer units reported that approximately 70% of obstacle breaches through June and July 1944 were accomplished using Bangalore's. The remaining 30% involved tank dozers, explosive charges placed by hand, or manual wire cutting. But those alternative methods required significantly more time and exposed soldiers to danger for longer periods. Bangalore's allowed rapid breaching under fire, the critical capability that enabled American tactical success. Cost-benefit analysis showed dramatic returns. Each Bangalore section cost approximately $15 to produce in 1944 dollars. A typical 40-foot Bangalore consisted of 8 sections costing $120 total. This $120 weapon could destroy obstacles that cost thousands of dollars and hundreds of man-hours to construct. More importantly, it could create breaches that allowed infantry to advance, tank attacks to succeed, and offensive operations to maintain momentum. The tactical value of maintaining offensive initiative was incalculable, but clearly worth far more than the modest cost of the weapons enabling it. The Bangalore's role extended beyond Normandy. In the autumn 1944 campaign through the Low Countries and into Germany, American forces encountered new defensive obstacles. The Siegfried Line, Germany's prepared defensive positions along the western frontier, featured concrete dragon's teeth anti-tank obstacles, pillboxes, and extensive wire networks. Bangalore's proved effective against the wire obstacles, though the concrete barriers required more specialized demolitions. The principles learned in Normandy, that obstacles could be breached rapidly with explosive charges, continued to guide American tactics. The crossing of the Rhine River in March 1945 saw extensive Bangalore use. German defenders had fortified the western bank with elaborate obstacle belts designed to prevent any approach to the river. American engineers used Bangalores to breach these obstacles under fire, creating paths for assault boats and amphibious vehicles. The speed of the breaching operations, accomplished in hours rather than days, contributed to the successful establishment of bridgeheads that led to Germany's final collapse. In the Pacific theater, Bangalore has found different but equally important applications. Japanese defensive positions on islands like Iwo Jima and Okinawa featured elaborate cave systems and fortified positions connected by trenches. Marines used Bangalores to collapse cave entrances, breach bunker walls, and clear trenches. The weapon designed for wire obstacles proved adaptable to diverse tactical situations, demonstrating the value of simple, robust tools that soldiers could employ creatively. The contrast between American and German obstacle warfare philosophy reflected broader strategic differences. German strategy focused on creating impregnable defensive positions, assuming that superior engineering and tactical deployment would stop enemy attacks. American strategy accepted that no position was impregnable and focused on developing tools and tactics to breach any obstacle. This offensive mindset, supported by industrial capacity to produce breaching tools in abundance, proved more effective than the defensive perfection Germany sought. Post-war analysis by military historians confirmed the Bangalore Torpedo's decisive role at Omaha Beach and throughout the Northwest Europe campaign. Studies concluded that without effective obstacle breaching capability, the D-Day landings would likely have failed at Omaha, possibly threatening the entire Overlord operation. The ability to breach obstacles under fire, creating multiple paths through defensive belts, was identified as essential to maintaining offensive momentum against determined defenders. German military professionals, analyzing their defeat, acknowledged American breaching superiority. General Gunther Blumentritt, Chief of Staff to Field Marshal von Rundstedt, wrote in post-war interrogations, "American engineers demonstrated exceptional capability in obstacle clearance. Their explosive charges were simple but effective. More importantly, they had unlimited quantities and were willing to accept casualties to employ them." German defensive doctrine assumed obstacles would channel attacks predictably. American breaching capability made this assumption invalid. This assessment captured a crucial lesson. Technological simplicity, combined with abundance and aggressive employment, defeated sophisticated defenses. The Bangalore Torpedo, ancient by World War II standards, mass-produced by the thousands, wielded by frightened soldiers struggling through surf and fire, broke the Atlantic Wall that years of German engineering had created. The victory belonged not to the most sophisticated weapon, but to the most practical one, available in quantities that made tactical failure at one point irrelevant when success could be achieved at another. The soldiers who employed Bangalores on Omaha Beach and throughout Europe were later recognized for their courage. Many received decorations for valor. Staff Sergeant Strechik received the Silver Star for his actions breaching obstacles under fire. Dozens of engineers received Bronze Stars, Purple Hearts, and other recognition. But many who died accomplishing critical breaches were never identified individually. They remained names on casualty lists, their specific contributions lost in the chaos of combat. The engineering units that suffered terrible casualties breaching obstacles received unit citations and battle honors. The 37th and 336th Engineer Combat Battalions were awarded Presidential Unit Citations for their actions on D-Day. These citations acknowledged not just the initial landing, but the sustained combat engineer operations throughout the Normandy campaign. The engineers had proven that combat engineering was not a support function, but a combat arm as essential as infantry or armor. For the men who survived, the memory of employing Bangalore is under fire remained vivid decades later. Veterans interviewed in the 1980s and 1990s could recall precise details: the weight of the sections, the feeling of screwing couplings together with trembling hands, the terror of positioning charges while machine guns fired overhead, the relief when explosions opened gaps in obstacles that had seemed impenetrable. These memories, individual and personal, collectively told the story of how simple courage and simple weapons defeated elaborate defenses. The lessons learned from Bangalore employment influenced post-war American military doctrine. The emphasis on simple, robust weapons that average soldiers could employ effectively became foundational. Complex systems that required extensive training or careful maintenance were viewed skeptically. The ideal remained weapons like the Bangalore, simple enough for universal employment, reliable enough to function under terrible conditions, effective enough to accomplish essential missions. The simple pipe bomb won the day.